We're going to look at two different scenarios in terms of finding equations to lines when we just know the 2 points and not a vertical intercept. So if we review the steps, we calculate the slope first, place one of the points, remember a point is an input and an output, and the slope into the general equation of a line, which is f of x equals the slope times the input variable plus the vertical intercept. Then we're going to solve for the vertical intercept, and we rewrite the function substituting the slope that we found in step 1 and the vertical intercept that we just found using appropriate variables into our equation. So this first equation that we're going to write just is a general equation with the points 5, -3, and -10, 7. And I've highlighted the inputs to be in blue, and that's going to help us over here in this application problem. So our first step is to find the slope. So our slope is the change in output, so that's going to be -3 minus 7 divided by the change in inputs, which is 5 minus -10, which is -10 divided by 15, which gives us -2/3. So step number 2 is to place one of the points, and it doesn't matter which point because both points lie on the line, and that's part of being a linear function. All the points are on the same line, and the slope into the general equation. So we know that this is f of x, which is the output, equals the slope times the input plus the vertical intercept. So I'm going to substitute my point, which is, I can use the first one here, -3 equals -2 times 2/3, which is my slope, times x, and x is my 5, my input, plus the vertical intercept. And now I'm going to simplify what I know. So I have -3 equals -10/3 plus the vertical intercept. As you can see, the only thing left that we don't know is the vertical intercept. So I'm just going to add 10/3 to both sides. And I can do this in my calculator by just putting parentheses around the 10/3. My calculator can do all the hard work. So my calculator comes out with 0.3 repeating. If I use the math fraction, I change that back to 1/3, which equals the vertical intercept. So now that I know the vertical intercept and the slope, I can rewrite the function. Since this is just a general equation, or a general 2 points, not in context, I can use f of x. It is a function, it's a linear function. The slope is -2/3. The input variable is x plus the vertical, not the vertical intercept, we know what that is now. We know that that is 1/3. So that's our equation to the line that would pass through these 2 points. Now if we look at this problem, the maximum speed of a semi-trailer truck up a steep hill is a function of the weight. Remember, the words after function of indicate the input, and so the weight is my input, so I know that the points given to me are 10, 45, and then I also have 50 and 25. As you can see, that as the weight increases, the speed is going to slow down, so this is going to be a line that goes downward. So again, we're going to calculate the slope. So the 45 minus 25 divided by 10 minus 50 is 20 over a -40. So this means that it's -1/2, and because this is a practical application problem, the input is weight and the output is miles per hour. So this means that at -1 miles per hour, it's going to 2 tons is our input. So that means as I decrease in my speed, the weight would increase, or if I increase my weight by 2 pounds, I'm going to decrease my speed by 1 mile per hour. So now we can use, rather than using f of x, let's use something that is going to make a little more sense. So since the output is speed, we use v for velocity, w for weight, equals -1/2 times w plus the vertical intercept. Now we're going to substitute some points in. As you can see, we calculated this out. Our vertical intercept is 0.50, and then this is our function.